Alright guys, so today what we're talking about is just a continuation, like I said. The first thing we're going to look at is the fundamental theorem of algebra. And that's down here. It says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. So what this is saying is that we have to have at least one solution if that degree of the polynomial is greater than 0. But the corollary is even more interesting and important. This one says that if the degree of the polynomial is greater than 0, then the equation has exactly n solutions, provided each solution that's repeated twice is counted as 2 solutions. Each solution that's repeated 3 times is counted as 3 solutions, and so on. So what this is saying is this is going to give us an exact number of zeros. So what is the degree for this first equation that we have here? You look for the highest power of x. So what's the highest power of x? So this would have 3 zeros. Those zeros that we find could be rational, irrational, they could be real numbers, they could be imaginary numbers. Alright, now what about the second one? What's the degree here going to be? 4. Good job. Because this should actually be written like this, in descending order. We always like to write our polynomials in descending order, and then this leading coefficient, that is what we're going to go, or not the leading coefficient, the highest power of our exponents, the highest value there, that is going to be the degree. So we're going to have 4 zeros on this one. Now on number 3, we're supposed to find all the zeros. How do we find zeros? What's one of the methods we can use? Factoring. We can factor by grouping. We can factor by setting up our double parentheses. So let's try factoring here. So I would set this function equal to 0. I'm going to set up my double parentheses. What times what will give us x to the 4th? Good. So we would have x squared and x squared. Now we need to look here. What are numbers that multiply to be 49 that subtract to be 48? 49 and 1. What about the signs on this? Yeah, this should be negative, this should be positive. So we want to keep factoring as much as we can. How would this factor down? This is the difference of 2 perfect squares. So how does it factor? Right? And this one is the sum of 2 squares. This cannot be factored further, so we just leave it as is. So now to find our zeros, we're going to have to set this equal to 0, this equal to 0, and this equal to 0. Solving this one, I'm going to subtract 7. I get x equals negative 7. Add 7. I'm going to get x equals 7. And for this one, I have to subtract 1. And I get x squared equals negative 1. So I'm going to have to take the square root. What's the square root of negative 1? I. So this is going to be plus or minus I. So our zeros are going to be x equals negative 7, positive I, and negative I. How many zeros were we supposed to have on this equation? And we got 4. So we know we're correct. Okay. Now on the next one, we would like to try to solve this with grouping, but we have 5 terms, so we cannot use grouping. So instead, we're going to have to think of those possible zeros. Those possible zeros we can have are going to be plus or minus these factors, which are 1, 2, 3, 4, 5, 6, lots of them, aren't there, 10, 12, dot, dot, dot. Now, I'm not going to write them all out because do you remember how I said it's generally one of these first ones right here? Yeah. So I'm not going to write all these out. Now, I can test 1 very quickly. If I plug in 1, I get the exact same values. 1 to the 4th is 1. Is 1 minus 3 plus 6 plus 2 minus 60, is that going to give us 0? Is that going to be a 0? No. What about negative 1? That would give me 1 plus 3 is 4 plus 6 is 10. That's not going to give me it either, is it? So 1 and negative 1 are not going to work. I'm not going to waste my time doing synthetic division with them. But 2, 3, 4, some of those might work. So let's go ahead and do synthetic with 2. So I bring this down, I got 1, multiply, add. Okay, I got negative 40 as my remainder. That did not work, did it? Okay, so what I'm thinking is 3 is, I don't know, 3 might work. Let's go ahead and try it. And what we're going to look at here too is faster ways of doing this synthetic division. Ooh, yay. You guys see why I'm saying yay? Because that did work. So 3 is one of our zeros. How many zeros am I supposed to find? 4 of them. So I only have 1 of them. Now, I have some other possibilities here. I know that plus or minus 1 didn't work. We already checked 2, it didn't work. What do you think we might want to check now? 6 might work. Okay, so now what I do, guys, is I'm going to use this. Okay, I'm only going to use this part of it. Remember what this tells me. This divides evenly. This is my constant, this is my x, this is my x squared. Okay, so I'm now going to just, this is my x cubed, sorry, x cubed. So now I'm just going to use these coefficients, 1, 0, 6, and 20. Now, guys, let's try to think of this. If we plug in 6, I don't think there's any way that's going to work, is there? Because these numbers are going to keep getting larger. So what are you thinking? That the next number must be a what? It's going to have to be a negative. Because if we use a positive, we're going to keep adding and these numbers are going to get too large. So maybe we try, you want to try negative 3? Ooh, no. But what do you guys think it might be then if it's not negative 3? Let's try negative 2. Boom, we got it. Okay, so x equals negative 2 is the other one. So now I look at this. Okay, I'm going to have to come over here. I'm running out of room. This is my constant. This is my x. This is my x squared. So now I have to solve this, right? Here's one of my zeros, 2 of my zeros. I have to find 2 more. How can I find the zeros for this? Are there numbers that multiply to be 10 and add to be 2? What are numbers that multiply to be 10? 2 and 5, 10 and 1, do they add to be 2? No. So what I'm going to have to do instead is I can use the quadratic formula or I could use completing the square. Which do you guys find easier? Okay, quadratic formula I heard somebody say. So I'm going to do x equals negative b, which is 2, plus or minus square root b squared, which is 4. So b squared minus 4 times a, which is 1, times c, which is 10, all over 2a. So I'm going to have 2 plus or minus, what's 4 minus 40? Negative 36, all over 2. Now, what's the square root of negative 36? 6i. So I'm now going to have, sorry, I need more room. I have 2 plus or minus 6i over 2. Do you guys know what those solutions would simplify to? Great. So my other zeros are going to be 1 plus 3i and 1 minus 3i. And we found all 4 of the zeros. That's a lot of work, yes. So So we won't have too many problems like that, just 1 or 2 problems. All right, let's come over here. This is the complex conjugates theorem, and this is the last thing we're going to look at. This says if we have a polynomial functions with real coefficients, if a plus bi is an imaginary 0 of the function, then a minus bi is also a 0 of the function. So if 3 plus 2i is a 0, what is the other 0? 3 minus 2i. Now it says to use the sum product method to find the quadratic equation that results in a solution of 2 minus 5i. Well, if 2 minus 5i is the solution, what's the other solution? 2 plus 5i. We want to know what's the quadratic equation that has these solutions. Well, what is the sum of those two? If I add those two, what do I get? 4. The product, these are binomials. I have to do first times first, which is 4. The outers give me plus 10i. The inners give me minus 10i. And the last times the last gives me minus 25i squared. You guys know, I heard somebody say it already. 29, right? That's because I squared is negative 1. So negative 25 times negative 1 is 25. These two are 0. We got 29. So can somebody tell me the equation? We'll call it G. What's the equation going to be then? Awesome. Okay? And so that's going to be the equation that's going to have those values for its solutions. Make sense? All right. So we're going to stop there.